Greetings everyone, my name is Thapelo Maseko. I'm a nanomedicine ambassador at Nabio Consulting. Today I'll be presenting about superparamagnetic ion oxide nanoparticles, which are sometimes called SPION. I will give their properties, the techniques that I use to synthesize them, and I will also provide their biomedical application. SPION are nanoparticles that are produced from ion-containing compounds such as ion pentacarbonate. They have unique physical, chemical, and biocompatibility properties that allow them to be widely used in biomedical application. Some properties of SPION include controllable size, light surface area, and non-toxicity. When I talk about the controllable size, I mean the techniques that I use to synthesize SPION allow SPION to be produced at different sizes, which is under the nanoscale. Light surface area. In chemistry, they usually say molecules that are associated with light surface area, they tend to speed up the rate of reaction. In terms of nanoparticles, such as SPION, their spherical shape allows them to deliver drug at a faster rate. Non-toxicity. The toxicity depends on the physical and chemical properties of the nanoparticles and on the dose of the drug that is intended to be used. SPION are suitable for biomedical application because their superparamagnetic nature implies that the particles will not be attracted to each other, and hence their risk of being toxic in the body is minimized. Another thing that we have to put into consideration is that iron is a naturally occurring metal in the body, and hence the body is adapted to metabolize iron, meaning that even if we can use ion-containing nanoparticles in therapies or in any biomedical application, it won't be a problem because the body is already adapted to metabolize iron. The synthesis of SPION. There are a lot of techniques that are used to synthesize SPION, which include water-in-all microemulsion, gas deposition, co-precipitation, thermal decomposition, and many more. Each and every technique has a specific performance, procedure, and condition which produce different nanoparticles, including the size of the particle. The two mostly used techniques to produce SPIONs are the co-precipitation and the thermal decomposition technique. I'll start by explaining the co-precipitation technique because it is considered as the simplest technique to produce SPIONs. It was discovered by Mazad more than 30 years ago. This technique involved the precipitation of ion 2+ and ion 3+ ion into magnetite in a basic solution. The advantage of this technique is that it produces a large number of nanoparticles in a reaction or prebench. This technique produces nanoparticles that are different in sizes because of the kinetic factors that influence nucleation and growth of the crystal. If you can carefully look at this picture on our left, we can see that ion 2+ and ion 3+ ion are being mixed in a basic solution to produce the ion oxide nanoparticles. Thermal decomposition. These techniques work by decomposing ion-containing compounds such as ion pentacarbonate and ion oleoate at high temperature. The reaction takes place inside the nonpolar solvent with the presence of capping agent. This technique produces hydrophobic nanoparticles that can be stored in nonpolar solvents such as hexane and cyclohexane. The advantage of this technique is that it produces high quality nanoparticles, and the disadvantage is that it produces less number of particles per band. If we can carefully look at this picture, we can see that ion pentacarbonate is being decomposed in a non-polar solvent and heated up to 280 degrees to produce the nanoparticles. The coating of SPION. Ion oxide nanoparticles without any surface coating are not stable in aqueous media and they readily aggregate. For in vivo application, the particles often form aggregate in the blood and are sequestered by macrophages. Therefore, the surface of ion oxide nanoparticles should be coated with a variety of different moieties that can eliminate or minimize the aggregation under physiological conditions. They are often coated with polyacrylamide and PEG copolymers. The structure of the SPION. A fully synthesized SPION must look like this one displayed on this slide. It must have a targeting ligand, which enable the nanoparticle to recognize antigen or receptors on the targeted cell. It must consist of a linker, which connect the targeting ligand to the surface of the SPION. A cell internalizing agent which help the nanoparticles to enter the targeted cell. Each and every nanoparticle is designed to carry or to deliver drug at some biomedical application. So the drug can be any drug that is intended to be used. A magnetic core. The magnetic core confine and guide the magnetic field during application. A fully designed SPION must also have a polymer coating, which improve biocompatibility and bioavailability of the nanoparticles. And lastly, it must have an optical imaging dye, which enable the display of physiological and molecular condition of the targeted cell. The uses of SPION in biomedical application. There are a lot of fields whereby SPION are being used. For example, they are used in drug delivery system. They are used in diagnostic MRI. They are used in magnetic and optical hyperthermia. Drug delivery system. In drug delivery system, SPION acts as nanocarriers to transport and release drug to a targeted cell. For example, the targeted ligand found in SPION enable the nanoparticle to recognize the specific antigen or receptors found in cancer cells. The nanoparticle will bind to the receptors and release the drug, which will eventually stop the growth of the cancer cell. If you can carefully look at this picture on this slide, we can see that nanoparticles containing the drug is being introduced into the bloodstream using an injection. And under a magnetic field, the nanoparticles is being directed to reach the site where they are needed, in this case, into the tumor cells. As soon as they reach the tumor cell, the nanoparticle release the drug, which will eventually stop the growth of the cancer cell. Hyperthermia. There are several cancer treatment methods that are being investigated by scientists. Some treatments include photodynamic therapy, photothermal therapy, and oscillation magnetic field hyperthermia, which is considered as the simplest and less risky method. This method works by concentrating the SPION carrying the drug into the tumor cell under a magnetic field. The magnetic energy is converted into heat energy. The heat energy makes the pore on the cancer cell to enlarge. This makes the SPION to overheat, release the drug, which will enter into the cancer cell and destroy them. If you can carefully look again on this picture, we can see that the nanoparticles are being introduced into the body using an injection. And under a magnetic field, the particles are being directed to the tumor cells. As soon as they reach the tumor cell, the temperature is being increased. As soon as the temperature is increased, the pores that are found on the cancer cell enlarges. These allow the penetration of the drug that are released by the nanoparticles to enter into the cancer cell easily. Therefore, the cancer cell will be eventually destroyed. SPION as magnetic resonance imaging agent. Magnetic resonance imaging is a biomedical tool that is used to visualize soft tissues to detect physiological and chemical changes in the body. This tool can be used to scan any part of the body, including the brain and the spinal cord. I'm sure most people are familiar with this machine. This machine consists of a magnet that produces a strong magnetic field that forces proton in the body to align to that magnetic field. When a radio frequency current is passed through the patient, the proton are stimulated, spin out, and pulled against the magnetic field. Remember, our body consists of water. In water, there are hydrogen atoms and oxygen atoms. In chemistry, they say that hydrogen atom can act as proton. The proton, which are in our body, are the ones that are being stimulated, spin out, and pulled against the magnetic force. The magnetic field that is produced by the magnet found in this machine. The MRI machine produces an image that looks like this one on this slide. The main advantage of MRI, it gives you the opportunity to obtain high resolution of soft tissues. In conclusion, the use of SPION in biomedical applications show a promising way to fight against different diseases in the future with reduced side effects. Other studies discovered that SPION can also improve the performance of other drugs in current use and enable drugs that had been previously ruled out due to systematic toxicity issues to be revisited. Thank you very much for listening.